All right, how are we doing this morning? I hope you're doing well. I'm going to go ahead and get us going on this and keep it as quick as possible by giving you all the information. I will have you pause a couple times and then I'll reveal the answers just so you have a chance to try something on your own. All right, here we go. What is the equation of this one in factored form? So if you haven't done that or you're waiting for me, let's go ahead and just factor it. If any exists, let's identify the equation of vertical asymptotes. Now you might be thinking I should write two, but I cannot write two vertical asymptotes because one of them is actually representing a whole. So I would actually have only one, and that is at x equals -2. Does the function have any holes? Well, yes, it does. It is at 2, and I have to plug that 2 back into the simplified form, which would be 5/4. Okay, if any exists, identify horizontal asymptotes or oblique asymptotes. I'm at the same degree, and when we have the same degree, we would write y equals the ratio of the lead coefficients, in this case is 1:1. What is or are the zeros of the function? Remember, zeros represent x-intercepts, so that is any factor remaining in the numerator produces an x-intercept, so we would have -3, 0. What are the y-intercepts? There's never going to be more than one y-intercept, or this wouldn't be considered a function, but that comes from the ratio of the constants, and so that would be 0, 3/2, or you could just sub in zeros everywhere and you would get 3/2. The domain and range of our function. Let's go ahead and look at this on the graphing calculator, so making sure we know, because we're also going to graph it. Your PDF has a much nicer graph. I don't know why mine is like this, and then so I made a little extra guide on there, but I'm going to go ahead and type this in. So that one is here as x squared plus x minus 6, and in the bottom, x squared minus 4. So in looking at the graph of this, I see a really nice looking function. I see my vertical asymptote. I see my horizontal asymptote. I can't see the whole, but I could check it out using the table feature, and I would see that they're at +2. I also have an error. -2 is my vertical asymptote. But you can't find the y value unless you do the method that I showed you by substituting in that value of the whole into the reduced form. So just by looking at this, I think we should be pretty safe. We could always check to see if the 3/2 is used at another time, or, sorry, not the 3/2, the 5/4, or the y equals 1 by setting our reduced form equal to those values. The equals to 1 is definitely not going to give me anything, and I believe the 5/4 actually gives me the value of the whole. So we're going to go ahead and skip all the things we're supposed to skip, and that means that my domain would be -∞, and I have to skip 2 x values in this. I'm going to have to skip -2 and +2. My range, I'm going to also skip 2 values. I'm going to skip 1 and 5/4. And there we go. And then sketch a detailed graph. So I'm going to pull my function back over here on my calculator. Detailed graph. Remember, the expectations are that you would graph your asymptotes. You definitely have to graph a whole. You would definitely have to graph oblique asymptotes as well. And then we want to make sure that we get 2 to 3 points on each of the branches. And we want to also get arrows on those. So I'm going to go to my table of values. My vertical asymptote we know is going to be at the -2, and my horizontal at 1. So -2 and at +1. So I got those graphed. I'm also going to put the value of the whole on the graph, and of course I can put my intercepts on there. So -3, 0 is a nice point to put on there, and 0, 1.5 is not bad either. And then I can put on my That was not the right point. What did I do there? I'm like, that's on the wrong side. Excuse me. Excuse me. Okay, we go back, go back, go back. Oh my goodness. Okay, so 1.5 is way up here. I graphed a half. I also can get my, what do I have there? My y. What is going on? Can I delete that? There, whoa! Here, 1.5. There we go. And I can get some other points. So let's get something else on there. -1, 2. So right there. And then I think I'm too zoomed out. I'm really struggling to look. And then 1, 1.33. I guess that's pretty good. And then you can connect those. I'm going to get rid of that for a second. And arrows. And then the other side, we can do this too. So let's get the other side of that asymptote. So at -4, and you got -1, +1/2. There we go. And then 0.666. So they're kind of some of them are going to be a little bit more challenging to draw because the numbers are so tiny. And we're approximating. There you go. All right, so go ahead and pause the video and try the next one, and then I will put the answers in the spots and we can take a look at it, but try the next one for me. Right, let me go ahead and use my little magic here so we can see that we got everything in the spots we were supposed to get it in. There we go. I did not ask the domain and range on this one. The domain would be a pretty easy one to find. We could find out what x values are being avoided, but as far as y values, we'd have a little bit more of a challenge. But hopefully you were able to get the top part and you were able to do your graph like mine. All right, so that was a nice little review, and we'll get to review again tomorrow as well. Let's walk through these next ones. Answer the following questions using the graph of the rational function pictured below. The graph of the function has a removable point discontinuity. Removable point discontinuity is another word for whole, and that is at 3, 5/3, and an x-intercept at -1/3, 0. So I want to go ahead and say it says what factor is guaranteed to be in the numerator, but not in the denominator. And what does that represent? So if it has to be in the numerator, but it's not going to be in the denominator, it has to be our x-intercept because that's what remains. And so I can see that down here. So what exists in the numerator that is not in the denominator. And so I would say that value right over here, that x-intercept, which we found up here to be -1/3. Oh, I just want to write x. What factor? So let's do that. So x minus 1/3 is not really how we would want to, or plus 1/3 is not how we want to write that. We'd write 3x plus 1. So this is what we want to have. I'm going to erase the other one. All right, what factor is guaranteed to exist in the denominator, but not the numerator? Now, what is that referring to? That's referring to your vertical asymptotes because that's what remains after simplifying. And so it's not going to be in the numerator, and that's my vertical asymptote, and that looks like that's at 3, so that's at -3, so that would be an x plus 3. And what factor is in both the numerator and the denominator, and that is what leads to your whole, so I would say that would be my x minus 3. What is my domain? This is more just looking at the graph. So what is my domain? Well, I would want to skip over my -3 and +3. And then what is the range? The range is going to be, I'm going to skip over the y value of my whole, which is written up in the top, which is 5/3, and I'm going to skip over 3. Here we go. If a is the leading coefficient of the numerator and b is the leading coefficient of the denominator, what is the value of a over b? So in this case, I'm going to be really looking at the ratio, right? Like I'm trying to draw attention to this ratio of the numerator and the denominator coefficients. And that would be that this would have to be a 3 over 1, right? Like I have to have a 3 over 1. Now maybe it's simplified, maybe it's not. And so let's take a look, okay. All right, so it doesn't actually ask us to write this equation, but I'm gonna ask us to write this equation. So we should have this function, I'll call it f of x, and what's guaranteed to be in the numerator is 3x plus 1. What's guaranteed to be in my denominator is x plus 3. What's guaranteed to be in both because of that whole is this x minus 3. And we've actually written the equation based on just identifying those things. Okay, I want you to take a look and see if you can get the equation to the bottom one. So go ahead and pause, and then I'm going to scroll up to number 20 when you unpause. All right, there it is. There is my function that matches my graph, and you can take a look at the factor that cancels, the factor that remains in the numerator, the factor that remains in the denominator. Did I get my x-intercept right? Did I get my y-intercept right? So let me know what you think of that and see if there's anything I can help with on that one when we're back in class tomorrow. All right, I'm going to walk you through another one of these. Let's take a look. Pictured below is the graph of g of x, the graph of a rational function. The coordinates of the whole are -2, 1/3, and determine if the following statements are true or false. So the domain of the function is -infinity to 1 and 1 to infinity. I'm hoping you said false because we also have to skip the whole. Because of the whole. So we have to skip -2 because of the whole. The degree of the numerator is less than the degree of the denominator. So this would imply that this is bottom heavy. And that answer is also false. Because if it was bottom heavy, we would have had a y equals 0 as our horizontal asymptote, and we have a y equals 1. So this must be same degree because of y equals 1 for the HA. Okay, this next question. As x goes to infinity, then the graph of g of x is going to 1. So that's an end behavior concept right there. Let me get that up the top. So that's saying that as x is going to infinity, is the y values leaning towards 1? And I would say that is true. That is our end behavior. The factor x plus 1 is a non-canceling factor, meaning it remains. And if it remains in the numerator, then it would imply that it is an x-intercept. And in fact, that looks pretty true to me because that is an x-intercept. Okay. The factor x minus 1 is a non-canceling factor in the denominator. If it's in the denominator and it doesn't cancel out, then that's leading to a vertical asymptote. And we got that at +1. Very good. And the range of the function is as follows. I think that looks pretty good. It looks like it skipped the right values, so we would put true. It did skip the horizontal asymptote and the y value of the whole. And we got these last two questions. The factor x minus 2 is a factor in the numerator and the denominator, and I would argue that that is, it's actually false because it should be x plus 2 in order to get that whole, because if it's in both, then that would imply a whole. And the value of g of 0 is -1. So that means when the function x is, when x is 0, y is -1, and that looks true to me. That is the y-intercept. Okay, moving onward. Okay, let's go ahead and try the top one here. So pictured below is the graph of the rational function f of x. Use the graph to answer the questions. The coordinates of the whole. I'm giving you the coordinates because I don't want you to guess at what the y value is, so that's why you're getting that information. What factor is guaranteed to be in both? We would say x minus 3 is in both. Why? Because that's where your whole is at. What can be said about the degree of the numerator and denominator? I would say they are the same. Why? Because I have a horizontal asymptote that is not at y equals 0. What factor is in the numerator that does not cancel out? So this not canceling out in the numerator is leading to our x-intercept, and so that must be at x plus 1 because there is a negative 1 as the x value. What factor is in the denominator that does not cancel out? That's leading to your vertical asymptotes, so we would say that that would be at x plus 2. Oops. Give a possible equation. So now we're going to do what we had done earlier is we're just going to go ahead and throw all that back together and put it together. So what is in both capital F of x, it says, would be an x minus 3 and an x minus 3. And then where the numerator has an x plus 1, the denominator has an x plus 2. Does this lead to the ratio of the lead coefficients working out for my horizontal asymptotes? I would say my horizontal asymptote works by being same degree and ratio of lead coefficients work. Does this give me an accurate estimation of my y-intercept? That would be a negative 3 over a negative 6. I think that looks right. My y-intercept also checks out. And let me explain that a little slower on that piece. Is that if I were to multiply these constants, I would get negative 3. And if I multiply these constants, I would get negative 6. So that would imply that my ratio of my constants is 1/2, and I see a y-intercept that would probably be at 1/2. All right, next one. Use the graph of the rational function h of x here and answer these questions. What is the domain and range? So we'll go ahead and take a moment. I'm just going to say it, do it silently. Okay, and then what is the factor in the denominator that is not in the numerator? And that is implying our x-intercept. So we'd probably have to, what factor is in the denominator? Oh, not in the denominator, not in the numerator. I read that backwards, but that would be the x plus 4. What factor is in the denominator and also in the numerator? That would be that whole value, so that'd be your x plus 3. And then this is that ratio of lead coefficients thing, and we know that that means we're talking about our horizontal asymptote, and so we know that that must be a 2/1. All right. Now, this last page here is given verbally, so here we're asked to do this with just the information, and we don't want to add extra information. So I'm going to start by writing an equation. So I'm going to start with f of x equals, and I know it's a rational function. They tell me the horizontal asymptote is y equals 0. This is telling me that it must be bottom heavy and that there's no hole. So I can literally write anything here. It just has to be bottom heavy and there cannot be a hole. So you really could write something like 1 over x squared in most simple form. You can certainly make it bigger and more detailed than that. So if you wrote something like x minus 2 over x squared plus 7, that's lovely. That is bottom heavy with no hole. That's all it asks for. Write a possible equation of a rational function with a horizontal asymptote at y equals negative 3. So this is implying same degree, and that we know we have to have a lead coefficient of negative 3 for that ratio, and a point discontinuity. Remember, point discontinuity means hole occurring at the value of x value of 2. So since I know that there's a hole, I'm going to start with that and put x minus 2 and x minus 2 in there. Because I have to have the same degree and I have to have a ratio where the negative 3 is there, I'm just going to put a negative 3. I have simply made this work, right? Like that's all I need. I got it. Write a possible equation of a rational function with a horizontal asymptote. So here we are again, same degree. And a vertical asymptote at x equals 2. So since it has to be the same degree, okay, and I know that, and I have to have a horizontal asymptote. So I know I have to have an x minus 2 in the bottom. I have to have a same degree. So how about just putting an x plus 9? I mean, whatever you want to do, right? It doesn't tell me anything. I know I have same degree now. I know that I've made this y equals 1 work, and I know I have a vertical asymptote. So that's enough. Okay, so let's go ahead and see what we got about these last two. Actually, why don't you go ahead and try those? I would rather not make the video to finish them. I think it would be best if you go ahead and try those last two and bring that to class, and we will open tomorrow with those two. And then, of course, any questions that you have on the assignment. I will post on Schoology what that assignment is so you guys can get started on it by 7:20 in the morning, but you can obviously see that this video is posted after school. But I will have the assignment posted by 7:20 in the morning. You guys have an awesome rest of your Tuesday, and I will see you on Wednesday.